Okay, so here are the examples for section 4.8 on Trig modeling and applications. And what we're going to be doing is we're going to be looking at some ship bearing. Now the key things to remember with ship bearing is you have to remember your compass. Your north, south, east, and west. Because everything, all the angles with dealing with ship bearing come off that north-south line. So it's really important that you understand where north and south are. And all these angles are going to be acute angles, so you're not going to have an angle more than 90 degrees for a bearing. The other important thing to remember is a little formula called distance equals rate times time. And that's how we are going to calculate all of our distances that the ships travel. The rate is going to be how fast it's going, which is our knots, and the time is how long it traveled at that. So with those two pieces of information, we can draw all our pictures. And that's going to be really important. So let's look at this first problem. A ship leaves port at noon, and I'm going to highlight parts of it, on a heading of due north at 35 knots. At 4 o'clock, it changes directions and goes north 42 degrees east and travels for 24 knots for 3 more hours. So I'm just highlighting the important information. At the end of 7 hours, how far has the ship traveled from port and what is its bearing? And that's what we're going to be doing in all of these, is we're going to be figuring out how far has the ship traveled from port in a direct line to that ship from the port, as well as what's its bearing now. So let's start with our picture. So I'm going to start down here, and I am going to start with my port, and I'm going to always put a little compass point here, just so to make sure I understand where my north, south, east, and west is. So this is port. Now from here, remember the ship traveled due north, so it went straight north for 35 knots. So I'm going to use my ruler, and I'm just going to draw a line straight north. It doesn't matter how long you draw it, just has to show that it goes due north. At 4 o'clock, the ship changed directions. So I'm going to put another compass point up here so that I make sure I draw the ship going in the right direction. So again, this is north, and our ship is going north 42 east, so it's going 42 degrees from this north line towards the east. And I'm going to move this paper a little bit, sorry about that. And again, the length doesn't matter. Alright, so this is our ship way out here. Now we need to know, we're going to find the distance from port to our ship. And it's just a straight line distance, so this is what we're looking for right here. This is our distance. And we're going to be finding our bearing. And our bearing is this angle right here. And the reason I know it's my bearing is it's coming off of that north-south line that I started with. It's the direction of the ship from that north-south line. So let's fill in some information that we know. Remember, the ship left at noon, and it traveled till 4 o'clock before it switched directions. So this is 4 hours at 35 knots. So our distance is going to be 4 times the 35, which is 140 miles, nautical miles. Then it switched directions, and it changed. This angle right here is at 42 degrees, because again, it has to always come off the north-south line, and we went there 24 knots for 3 hours. So this distance is 24 times 3, or 72 nautical miles. I guess I should put the yellow in there. Okay. Well, I have everything I need to know to find that distance that the ship has traveled. Now if you remember your trig, I have a side and I have another side. I have two adjacent sides. I need an angle somewhere. Well, going back to geometry, if this angle right here is 42, this angle right here is going to be its supplement, or 138 degrees. The two of them are going to add to be 180. Alright, so looking at this, I have a side angle side situation. And because of that, that means I have a law cosine situation. So my distance is going to equal the 140 squared plus the 72 squared minus 2 times 140 times 72 times the cosine of my 138 degrees. Now I just have to solve for d squared. So we're going to pull out our calculators, and I'm going to type that in my calculator. 140 squared plus 72 squared minus 2 times 140 times 72 times the cosine of 138. And that gives me my d squared, which is 39,765.79968. But I don't want d squared, I want d, so I'm going to square root that. And that gives me 199.4136 nautical miles. Okay, so that's how far the ship has traveled from port. But we're only halfway done with it. Now we need to do our bearing. So now I have to find this angle in here. And again, I'm going to use law of cosines. Remember, if you start with law of cosines, you have to do a second one. So to get this angle right here, and I'm going to call this theta, it's going to equal the opposite side squared equals the 140 squared plus the angle, the side we just found, minus 2 times that 140 times 199.4136 times the cosine of alpha, of theta. Now I'm trying to find that cosine of theta, so I'm going to solve for that. And so just by doing some manipulation, moving the squares all to one side and then dividing, which you should be used to with the law of cosines by now, I get the cosine of theta equals 72 squared minus 140 squared minus 199.4136 squared, all divided by negative 2 times 140 times the 199.4136. Now using our calculator, we already have the previous answer saved in our calculator. So using parentheses, I'm going to go 72 squared minus 140 squared minus my set answer squared divided by negative 2 times 140 times my answer. And that gives me the cosine of alpha of theta is 0.9704. Do inverse cosine, and that gives me that theta is 13.9807 degrees. So we have the angle there, but that's not the bearing. We now need to put in which direction it's going. Well, we can see that the ship moved finally in a north by northeast direction. So we say north 13.9807 degrees east. And this is our bearing. Okay, so that's the first one. All of them are similar to this. So let's keep going. Okay, so now we're on example 2 for section 4.8. We've already done the first example. So now we just start by drawing our picture. If we look at again, our example says a ship leaves port at 10 a.m. and heads due west at 20 knots. At noon, the ship changes direction to north 54 degrees west. Find the ship's bearing and distance from port at 3 o'clock. So again, the same thing. We're going to start by drawing our picture. Alright. Again, I'm going to start with my little compass point. Now, I'm heading due west, so I'm actually going to move it a little bit to towards the more the middle. Alright. So again, this is my north line. So due west means I'm going straight to the left for a certain distance. Then I'm going to change directions at noon and head north 54 west. So that means I'm moving to the upper left-hand corner in this direction. Alright. Again, this right here is 54 degrees. So from that north-south line, that's 54 degrees. Find the ship's bearing and distance at 3 o'clock. So I'm going to draw from my port to my ship. I'm going to draw a straight line. And so this is my distance right here that I'm looking for. So let's find the distance first. So the ship left at 10 and it switched directions at noon. So that's 2 hours at 20 knots. So 2 hours at 20 knots. So this has a distance of 40 nautical miles. Then from noon to 3 o'clock it didn't change speeds. Alright, so it's still going. It's still going 20 knots. So this is going to be 20 times 3. I thought it switched directions, or switched speeds. I guess it didn't. So this is 60 nautical miles. Alright. Alright, I'm looking at some. Okay. So now let's find our distance. Well, if you notice here, we need our angle again. So that's this big angle right here. I know that this is 54. This on a compass is going to be 90 degrees. So 90 plus 54 is 144 degrees. So there's my angle. So to find our distance, d squared equals 60 squared plus 40 squared minus 2 times 60 times 40 times the cosine of 144 degrees. Using our calculator, we have 60 squared plus 40 squared minus 2 times 60 times 40 times the cosine of 144 degrees. That gives me d squared equal to 9,083.21 or 2816. Okay, take the square root, and d is equal to 95.3063 nautical miles. Alright, so now I have the distance from port that the ship has traveled. I have to find the bearing. So the bearing in this case, again, is always off the north-south line. And that's going to be right here. This is my bearing. Notice, this time the bearing is outside of our triangle. So sometimes our bearing is going to be on the outside of our triangle. So we have to make note of that. So what we're going to have to do is we have to find, this is going to be our angle, this is going to be our theta, and then we're going to have to take it away from 90 degrees. So let's find theta. So I'm going to take my opposite side of 60 squared equals the 40 squared plus our 95.3063 squared minus 2 times 40 times 95.3063 times the cosine of theta. Solving for cosine of theta, I get 60 squared minus 40 squared minus 95.3063 squared, all divided by negative 2 times 40 times 95.3063. Using our calculator, I'm going to put a parenthesis and I'm going to go 60 squared minus 40 squared minus my answer squared divided by parenthesis negative 2 times 40 times my answer. And that gives me that the cosine of theta is about 0.9290 to our inverse cosine, and that gives me theta is about 21.7181 degrees. But like I said, that's theta. I don't want theta, I want my bearing. So my bearing is going to be equal to 90 minus that 21.7181. So 90 minus my answer. My bearing is 68.2819 degrees. Now which direction did I go? I went north-west. So this is going to be north-west. Okay, so there's example 2. It's a little different than example 1 because we have to pay attention to our bearing, whether it's on the inside of our triangle or on the outside. Let's go on to example 3. Example 3 is on the bottom of my paper, so let's go for it. So a boat leaves port traveling due west at 42 knots. After 6 hours, the boat changes course to north 35 degrees east and travels at 31 knots for another 5 hours. At the end of 11 hours, determine the distance the boat has traveled from the port and what is the bearing from port that the boat has traveled. Okay? So let's draw our picture. So again, we're going due west. So I'm going to start by moving my picture just a little bit on the right side, so I have the room to move west. Again, this is north, so I'm going to go straight left for a certain distance. After 6 hours, the boat changes course and goes northeast. Well, that means it's going to come back towards itself. It's coming up here. For another 5 hours. Now, you might be wondering, well, how do I know that it didn't go past the north? the first spot? Well, it's slowed down for one, and it's a less amount of time that it's traveled. So find our distance from port, and I'm going to make this one in red. Okay, so this is my distance. And my bearing is going to be this angle right here. Okay, it's going to be that angle on the outside again. So let's find the missing parts. So for due west, we went 42 knots for 6 hours. So this one, distance is going to equal 42 times 6. I'm going to get my calculator out for this. 42 times 6, and that gives me 252. 252 miles. Now that 33 degrees, that's this angle up here. And it traveled for another 5 hours at 31 knots. So this one is going to be 31 times 5, which is 155. Okay. All right. Okay, just give me a second here. You're reading the problem, making sure I've got my numbers right. Okay. So let's find our distance. So again, we're going to do log cosines. I have my two sides. I need my angle. So that's this angle down here. I need this angle. Now, well, that's going to be 90 minus 33, or 57 degrees. All right, so let's do. So d squared equals 155 squared plus 252 squared minus 2 times 155 times 252 times the cosine of 57 degrees. Get our calculators out. 155 squared plus 252 squared minus 2 times 155 times 252 times the cosine of 57. Okay, did I type that in right? Nope, I did right. Okay. Thought I saw a plus sign there. Equals 44,981.79858. Do our inverse, or excuse me, our square root of our answer, and we get d is equal to, is about 212.0891 nautical miles. Alright, so now I have my distance. Now I need to find my bearing. So I'm going to make this theta, so that's the angle we're going to find, and then we have to take it away from 90 to get my bearing. Alright, so the opposite side of theta is 155, so 155 squared equals 252 squared plus 212.0891 squared minus 2 times 252 times the 212.0891 times the cosine of theta. Same as before, we're going to get cosine of theta by itself. cosine of theta equals 155 squared minus 252 squared plus, or excuse me, minus, I'm sorry, 212.0891 squared all over negative 2 times the 252 times the 212.0891. There's a lot of 2's there. Alright, so the cosine of theta is going to come out to be 155 squared. Hold on, wait, I forgot my parenthesis. 155 squared minus 252 squared minus 212 point... What am I doing? I need to just type in second answer. What am I doing? Here we go. Trying to get ahead of myself. Alright. Second answer square. There we go. Alright, Claire, let's just start over. Parenthesis, 155 squared minus 252 squared minus the second answer squared. There we go. Divided by negative 2 times 252 times my answer. And that gives me the cosine of theta is 0.7901. Inverse cosine. And theta is about 37.8010 degrees. Now we're going to take that away from 90. So my bearing is that 90 minus theta. So 90 minus my answer gives me 52.198. Now it's going to come out to be 90 degrees. Now let's look at our direction. Which way is the ship from port? This was port. It is northwest of port. So it's going to be north 52.1990 degrees west. Okay, so that's example 3. Notice you're doing the same process over and over. The key is going to be in drawing your picture. Okay? Alright, we have one last example, and then we are done with this lesson. Okay? So, a boat leaves port at 8 a.m., heading at north 45 degrees east at a speed of 35 knots. At noon, the boat changes direction and heads south 31 degrees west at a speed of 41 knots. The boat reaches its destination at 3:30 p.m. How far has the boat traveled from port, and what is its true bearing? Alright, so let's draw our picture. So let's start with our compass point, where this is north. And I'm going to go northeast at 45 degrees. Let me make sure I get it right. So I'm going to go northeast at 45 degrees. Okay. At noon, the boat's going to change direction and now it heads southwest. So it's going to head towards back here at 41 knots. So it's actually going to go like this. This is going to be a really weird picture, guys. And the reason, and I drew my boat passing port is because if you look, from 8 to noon, we went 35 knots. So in 4 hours, we went 35 knots. That's a distance of 4 times 35 is 140. From noon to 3:30, we went 41 knots. So that's 3.5 hours at 41 gives me 143.5 miles. So we're past our port. So we went a distance longer when we came back. All right. And so this is our distance right here. Again, this distance is 35 knots at 4 hours, because the distance from 8 to noon is 4 hours. And that's 140 nautical miles. The other distance backwards is 41 knots at 3.5 hours. And that's going to give me 143.5 nautical miles. Now the hard part here is going to be our picture. Is trying to get our angles. So this right here, this was 45 degrees. Alright. So that means that this right here is also 45 degrees. Now this is going to help us with finding our bearing. Because we don't know this angle down here, we can't use this angle. But the other angle I have is this one up top, and it's kind of hard to see. So I'm just going to kind of make a bigger picture up here. The first one came in at 45, and then it left out at 31. So we need to take that difference. So this angle up here is 45 degrees minus 31 degrees, or 14 degrees. So that's our angle up there. So now we can do everything we did before. We can find our distance. So d squared equals 140 squared plus 143 squared, 0.5 squared, minus 2 times 140 times 143.5 times the cosine of 14 degrees. D squared equals, get our calculators out, 140 squared plus 143.5 squared minus 2 times 140 times 143.5 times the cosine of 14. Okay? So d squared is equal to 1,205.7677. Do the square root. And d is about 34 miles. 7,242 nautical miles. So it's really not that far from port. But now we have to find our bearing. Now the key is going to be, where is this bearing? I know this is 45, this one's 45. I don't know this part, but our bearing is actually this right here. This is our bearing. It's on the outside of the triangle again, so I need to find this angle on the inside. And so what I'm going to do is I'm going to make this theta, this little part that I don't know, I'm going to make that theta. So once I have this whole angle here, I'm going to take away 45 to get this part, and then I could take it away from 90 to get my bearing. Or, if you notice, if I get this whole angle here, I could add 45 to it, and then take it away from 180. So there's a couple of things we can do. So let's find this angle in here. That's going to be our key, is we have to find that angle. And so I'm not going to use alpha this time. I'm not going to use theta, I'm going to use alpha. So the opposite side of that is 143, so I'm going to go 143 squared, 0.5 squared, equals the 140 squared plus the 34.7242 squared minus 2 times the 140 times the 34.7242 times the cosine of alpha. Solving for cosine of alpha is 143.5 squared minus 140 squared minus 34.7242 squared, all divided by negative 2 times 140 times the 34.7242. Okay, using our calculator, parenthesis, 140.5 squared minus 140 squared minus my answer squared, close my parenthesis, divided by negative 2 times 140 times my answer, gives me 0.02, so the cosine of alpha is about 0.02196. Well, we're still going to do our inverse, so it doesn't matter if we round or anything right now. Second cosine, second angle, our answer, and that gives me that alpha is 88.7416 degrees. Okay, so that's the angle on the inside of the triangle. So again, like I said, we could do a couple of things. I could add 45 to this and then take that from 180. That's going to give me what's left over. So let's do that. So I could say 180 minus the 88.7416 plus the 45 is going to give me my bearing. Using my calculator, 180 minus my answer plus 45 gives me a bearing of 46.258 degrees. Now which direction am I? Well, I am southeast, so it's southeast. Okay, so there's our examples for 4.8. If you have questions, make sure you come to class with it. Again, the key things are going to be drawing your picture correctly and knowing where your angles are. Thank you.